Okay, let's begin again. Yes, thank you. Why is it so... That's weird. Oh well, here we go. So... Oh, it stopped. Why did it stop recording? Has it stopped recording? I don't even know anymore. Oh, it is recording. How about that? All right, let's begin. That's going to be funny. It's going to be on YouTube because someone's going to listen to this. It's like, is this recording? It's not recording. Yes, it is. Oh, yes, it is. Okay, here we go. So we got a Ferris wheel, 5 meters above the ground. So let's say this is you standing and you're 5 meters above the ground. It's Ferris wheel. Yeah? You're 5 meters above the ground, and it says that each seat is to be filled, and once all seats are filled, the ride begins for and lasts for 6 minutes. Okay, the height is h meters, so you got h is in meters, and it tells you that the time is in seconds. So the first thing you should be noting that the time in 6 minutes, 6 minutes in terms of seconds, 60 times 6. It gives you 360 seconds. Okay, so you know that your maximum domain is already from 0 to 360. The first question tells you that use a calculator to sketch the following graph. H against T for the first 2 minutes, not 6, 2 minutes. First 2 minutes means that you are now having 60 times 2, which is 120 seconds. Okay, so that means if I were to do this, I'd say, all right, use my calculator, and this is where I'm saying be careful with where the degree symbol is going to be. You change the calculator, you either change the calculation mode, okay, so instead of radians, you change it to degrees, then you don't have to worry about it, type it the way you see it, or you type in your calculator like this. Okay, and like this is what I meant by 10t degrees will tell it that it is in degrees and the minus 45 degrees. So hence, before you do the sign of the angle, you already know the angle is in degrees, not radians. Okay, if you left the degrees on the outside, it calculates it in radians before it turns to degrees. And you'll find that when you sketch it, it looks weird. Yes, Emma?
I got a question. What happens if you just leave like your calculator mode in radians, but then you times the whole 10t minus 45 by pi on 180? Would that still work?
Yes, that would fine. That'd be fine. Yeah. So then, yeah, so that's the other alternative as well. You can change the radians algebraically in your equation times by pi on 180. Yeah. Okay, so if you do it that way, now if you sketch it, and remember the domain is 120 seconds, then you should get this. Now I defined the function first. I defined it first and then I sketched it, and it should look this nice. If you didn't do it properly, then you find this question, it will look very bizarre and hence you can't answer the question. So the other thing to note as well is I find that students, when they're doing their SACs and whatnot, this is one of the common problems. The question might be in terms of T or D or S or C or A, and when you find the derivative, it makes sense. But when you type in your calculator, you normally write it in terms of X. And so what happens is you normally write your answers in X. Be careful, this is in terms of T. So when you type out your function, type in terms of T as well. Okay, so if you wrote X over here, and then you wrote T over here, it doesn't work. If you're going to use T, then you have to use T and T. But then the problem to that is when you're sketching it, it's a y-axis to x-axis, so it's not going to sketch it either. Okay, so just be careful that depending on the question, you've got to remember the x is the t. It's just a different letter. Okay, so once you sketch it, pretty cool. Part A is pretty straightforward. You're like, that wasn't hard, sir. I'm like, yeah, that was the hardest part. Everything else is going to be straightforward. The second part, B, tells you how far above the ground is Isabel's seat at the commencement of the ride. Now we knew for the Ferris ride, it was 5 meters above the ground, so she is commencing already at 5 meters above the ground. So naturally, you're just asking when is h equal to 5. Logically or graphically or visually, you're just asking when it's equal to 5, what's your x-intercept? That's all. You're just, oh, not your x-intercept, just what solutions will give you 5. Okay, you're asking when h equals 5, what is t? That's what you're really asking. So if I answer the question, I'm just saying at the commencement, t equals to 0. And I know that I can just say when t equals 0, sub it in at the very commencement. I can already figure out where you're starting, which I know it should be 5 anyway. Okay, and it tells you it's at 5.8934. So that's where you're commencing when t equals 0. Okay, very straightforward. So it just tells you at the commencement. Well, you know that's when t equals 0. Sub it in, and you get your point where you actually start. Okay, now. The next part is, after how many seconds does Isabel's seat pass the access platform? Now, the platform was 5 meters above the ground. So that's what I'm saying here. Well, you know the platform is 5 meters above the ground. So as she's moving around, how long before she reaches again 5 meters? So that's when h equals to 5. I can look at the graph and I can either sketch h equals 5 or I can solve on the calculator. It's up to you how you want to do it, whether you want to do it on a calculator or whether you want to sketch it. So for me, if you were to solve it in your calculator because you defined it, it makes it so easy. So this could be a SAC question. You don't have to retype the equation. You can just say if you defined it with a restriction, okay, because I already defined it with a restriction. And so I knew it was from 0 to 2 minutes equals to 5. What are my solutions? And this tells me my solutions. Now notice there are a few more solutions there. So you can just count that. Or the question says, after how many seconds does Isabel C pass the access platform? So once she left and she comes back, well, the first answer was x equals 27.5. Or alternatively, you could have just sketched and put the 5 in, and you put the y values in, and you could have solved that too. You could actually find the intersection and get that first coordinate. It doesn't matter. Visually or calculator-wise, you would get the same answer. Now, in this question, I'm just answering how many times will a seat pass the access platform in 2 minutes. Technically, in my previous answer, I could have just counted my answers. I could have counted how many solutions there are. There's 1, 2, 3, and if you kept going through the calculator, you found another 3. You would have been able to answer part C and D on the 1. Okay? Yes?
Wouldn't that solution give it to the other side? Like when it's 5 meters above. Like look at the diagram.
Yep.
Yeah, that. Wouldn't it give it to that other side 5 meters above?
No, because the thing just moves around. So it's just going up and... Oh, you're asking... Oh, I see what you mean.
Yeah.
I see what you mean, because you would hit 5 meters... Oh. That's interesting. So you would calculate for every period then? Oh. That's interesting because the answer in the back, they didn't calculate for that. They just calculated as for every 5. But technologically...
Maybe that was the very bottom one.
Unless the platform was on 5, like maybe it looks like this. That's a platform, potentially.
It could just be down the very bottom.
It could be right at the very bottom, so we don't know. I just drew it the way I thought it might have been, so maybe I'm drawing it wrong. Okay, so we don't know. So for this argument's sake, I guess we don't know, so we're going to say it's 6 times. But if we knew it was the diagram I drew, then you're right. We'll access it once, yes. Good point. I didn't even think about that. That's true. Okay, next one. So, counting the number of times. Yes, you can do it either graphically or you can do it on a calculator to find your points. So the only thing you have to be careful of is by inspection, you either look at it on a graphically or you look at your domain from 0 to 120. Make sure you define it. And on your calculator, you can see that there's 6 points if you draw the graph of y equals 5. Or if you solved it previously, you would have known there was 6 solutions. So it's up to you which one you want to use. But you can see I'm already up to D. The question wasn't hard. It was either let h equal to 5, solve, or let t equal to 0, solve. Yeah? Now on to the next one. How many times will a seat pass the access platform during the entire ride? Well, I know the entire ride was 6 minutes. So the only difference from this question to the next question is, instead of restricting the domain from 0 to 120, now it's all the way to 360. And that's the only thing you're changing. And so if you did that, you can count the number of points, or you can do solve and count the number of solutions. It's up to you which one you want. But the question isn't hard. So it's 1 A, B, C, D, E. Then you go up to the next question. It says, now how far above the ground is Isabel stranded? If we knew that she gets stranded abruptly after 1 minute and 40 seconds. 1 minute and 40 seconds technically is 100 seconds after they commenced. Because it's 100 seconds afterwards, you just ask when t equals 100. So the question isn't hard, it's more in context. When you read the context, can you interpret what it's trying to say and answer it? And that's what your SACs are going to be like. So you see when you're doing the exam questions, that's what you're doing. You've got an equation, you've got a graph, interpret it. And that's the hardest part, to be able to take a graph and then interpret it logically. Okay? And so once we get t equals 100, we know that's 4.2, so you know you're 4.2 meters above the ground for Isabel. Now the hard part to me, I think the only hard part would be the next question. This is the last part of the question, was this one. So now that you know it took 100 seconds and she was 4.2 meters above the ground, the question is, if Isabel had a brother named Hamish, and his seat was 1.5 meters above the ground at the commencement of the ride, how far above the ground is Hamish when he's stranded? That's the only thing that I thought maybe would have pushed your thinking and go, all right, so now we know that Isabel got stranded after 100 seconds and she was 4.2 meters. The question is, how do you find Hamish if you knew he is 1.5 meters above the ground already? Okay, so when she started, she was at the very beginning, t equals 0. How would you solve this? See, this could be a SAC, and that would just be the only one that would get you thinking. Everything else was very straightforward. How would you answer this question? What would you do? We know that after 100 seconds, they get stranded. We just don't know where Hamish is now. How do we find where Hamish is? Yes, Corinne?
Could you find the x value at y equals 1.5 and then see where after 100 seconds after that, so add x plus 100 and then find the y value?
Perfect. That's exactly what you do. What she's really saying there is, at 1.5, because we know he's 1.5 meters, so what we're saying is h equals 1.5. What we don't know is, how long did it take for him to get to 1.5 to begin with? Because that's where the commencement was. So we knew after 100 seconds, they got stranded. Then whatever time he started, if he was 3 seconds when he was sitting in it, when he was 3 seconds in 1.5, then plus another 100 seconds, that will tell you where he would be. Because you know after 100 seconds, he'll get stranded. So the very first step was, since Hamish had a seat at 1.5 meters above the ground at the commencement, then we want to know how long would it take for you to reach to 1.5 if you were following Isabel's sort of graph. This is Isabel's graph. So how long does it take to get to 1.5 meters? And that's right, you solve for x. And that's what I did. I just said, if h was equal to 1.5, solve for the time. And this will tell me all the times. Now, I just want to know how long it took from the commencement. It took 31.5 seconds to get there, to reach 1.5 meters. So that's where Hamish would have been. Hamish would have been there to begin with. And so he was at 31.5 seconds. That's where it was. That commencement, that's where he was. Okay, so he's 31.5 seconds ahead of her. That's what it is. So if it took 100 seconds afterwards for her to get stranded, then it's 100 plus 31.5. So 131.5 seconds afterwards, that's when he gets stranded. Because for his commencement, he commenced here. She commenced at t equals 0. So he commenced at t equals 31.5. Technically, on his graph, he's t equals 0. On her graph, she's t equals 0. You're just asking what's the difference in time. How long before she reaches 31.5? And how long does he reach the next point? So if we know that it took 100 seconds to get stranded, the question is, whatever his time is right now, add another 100 seconds. So it's 31.5 plus, and now you know what the distance is. If you know how long it took overall, you can find out his height. And so, with that logic, you can then say, all right, Hamish is 31.5 seconds. That means after 100 seconds, 131.5. Then you're just asking, what height is he at 131.5? Because that would have been the height when Isabel reaches at 131.5 seconds. That's the height. That's the same time. And so we know it's 13.89, and therefore he would have been 13.9 meters above the ground. And that would have been the only question that I thought in question 6 would have been hard. Everything else was very straightforward. Okay, the only thing you have to think about is, because you only got the graph of Isabel, you had to imagine if it was Isabel at 1.5 meters, how long would that have taken? How long would it have taken Hamish to get there? Okay, so that's the only question I thought. But to put things in perspective, I also want you to have a go at this question. This is VCAA 2011, was 6 marks in total, and it follows the same thing. It's very straightforward at the start, and then the last one gets you thinking. Okay, so I want you to have a go at this. It's combining all the context that I've said. It's multiple area of study. You've got calculus in there. You've got your trigonometry, and you've got your trig ratios to understand and apply. This is the last question of VCAA 2011. 2011 was an easy year, but that was their hard question for exam 1. No calculators allowed. Okay, please have a go. It's the last question I'm more interested in. Now, I've got all the solutions up here. I'll go through it in the next, give it 1.5, so give it 9 minutes. I'll give you 9 minutes to do this question, and then go through the solutions. Okay? Let's go. 9 minutes, have a go. 2011, exam 1.
I didn't get the last question. The chicken.
Oh, okay. Wait. Just one before. Let's have, do you have a pen and paper?
It's a big deal. Oh my God. I'm so sure. What is that angle? Big deal.
you have all next week.
Yeah, we'll do that around.
Wasn't last night?
Have you done something wrong?
Try to sing for me. That's differentiated. I'm the weird one from Australia.
Yes. Not allowed a scientific calculator. Or CAS. It's exam 1. All right, let's go through the answers. So the first one, I think if you had a look and you had the first step to it, you would have got the answer. Then the links to the next one, and maybe C or D becomes tricky, right? So the first one, the very first step you should see is that they're asking you to find BD, which is this length, and then find CD in terms of A. So the very first thing is you should be focusing on that shape right up there, which is a triangle, and it's a right angled triangle. So the very first thing you should have got is if a right angled triangle, you got theta, then you should be thinking back in year 9, your trigonometric ratios. And your trigonometric ratios, you know, this is your opposite, adjacent, hypotenuse. So we can then say cos theta, which is adjacent over hypotenuse, is BD, the length of BD, over your hypotenuse, which is A. So if you rearrange that equation, adjacent over hypotenuse equals to cos theta, then therefore BD must equal to A times cos theta. Yeah? And then same thing with sine. If you did sine, CD over A, and you get A sine theta. So that's your first step, realizing that trigonometric ratios, you got SOHCAHTOA. Yeah? Once you got your SOHCAHTOA, then the next question is pretty straightforward. You then say, find the length L of the wire in the frame, including length BD. So it's really just saying find the perimeter. So it just says add that length, add this length, add that length, add this. Put it all together. You already got BD, you got CD, so you can answer this question and say, well, the length of it would just be 2 plus the 2 plus BD plus BD plus CD and then plus A. And so you would have got your answer as 4 plus A plus 2A cos theta, which is your twice of your BDs, 2 BDs, and then plus A sine theta, which is CD. So part B was easy. Then you would have gone to C. Oh yeah, that's just me. C tells you that find the derivative of your length equation in terms of theta, by theta. So, and therefore, if you had to find the derivative, it's just find the derivative of this. A is a constant, you don't need it. You need the theta, which is the variable. So derivative of 4 is nothing, and derivative of A is also nothing. The only thing you had to find the derivative was 2A cos theta and A sine theta. So if you knew derivative of sine, which is cos, then it's A cos theta. Derivative cos, negative sine. So you get this, negative 2A sine theta and plus A cos theta. So you found the derivative. Now hence show that when it's equal to 0, BD equals 2CD. Now this might be tricky for some. If you actually let dl d theta equal to 0, because if it had to equal to 0, that would imply that, by rearranging the equation, that would imply that 2A sine of theta equals to A cos theta. Yeah, all I'm doing is I'm just saying, if this equals to 0, negative 2A sine of theta plus A cos theta, I'm just saying, if that is true, that means that if I add both left and right by 2A sine theta, then I would get 2A sine of theta equals to A cos of theta. That definition will be true if it's equal to 0. If that is true, then I can rearrange this now because it's sine theta, cos theta. The very first thing, as soon as you see sine and cos, you should be thinking of tan. You can divide both sides by A cos theta. And if you do that, And if you do that, you got your, and remember theta won't equal to 0 or equal to pi 2, so it won't equal to 0. And so you get 2 tan theta equals 1. Tan of theta equals half, which implies opposite of adjacent. Tan of theta is opposite of adjacent. So that means CD over BD, okay, which is your length sine of theta, cos of theta. Yeah? And so therefore you can say 1 over 2 equals C D BD, and then you can do the cross multiplication of both sides, times BD on both sides, times CD on both sides. So that will give you BD equals 2 CD. Okay, so that's proving that if it was equal to 0, this is the ratio definition for C. Okay? Hands up if you got this question. Right, cool. All right, awesome. Then you got your next one, the last one. I said that would have been the tricky one. Yeah. Oh, Roberto.
The other way, and just show that BD equals 2 CD.
That's a good question. Can you show BD equals 2 CD?
No, can you
Work it the other way.
assume that and then show that because
I would think it's possible, but I'll need to get back to you on that one. It's the wording of the question that is important. Yeah, I'll get back to you on that one. Yeah. All right, listening. If you weren't listening to Roberto's question, he was asking, what if you showed it the other way around? So if you proved that BD equals 2 CD and then show that it equals to 0, can you do it that way? I'm almost inclined to say no, but I'm not sure yet. I need to go back and just check on the wording and confirm with the other teachers what they think. Yes?
What you've shown is if the derivative equals 0, then that happens. But it should be if BD equals 2 CD, then the derivative is 0. Like the logic is supposed to be reverse. So a substitution follows that.
Oh. So you're saying it should be this one before that one?
So if BD equals 2 CD, then
show that this equals to 0. Whoa. I'll check the examiner's report on this one, see what they've taken on that idea.
because in the derivative it's adding a cos theta and that's BD.
Okay. Oh. Alright, very cool. I'll have a look at that and I'll confirm that with you. Okay. Alright, now, the last one was find the maximum value of L. So you got the equation. You got the equation for your length, and they're telling you what A would equal to. It goes back to that triangle again. You got your derivative. Since you know that tan theta equals to 1 on 2, or you can use your previous property BD equals to 2CD, then you could say that A, or the hypotenuse, equals 2 using Pythagoras' theorem, 1 squared plus 2 squared equals to 5, so hence it's root 5, and therefore you can find out sine theta. So going back to sine theta is opposite over hypotenuse. So if hypotenuse is root 5, you got 1 on root 5, and you got cos theta is 2 on root 5. Therefore, you can now replace all of these values with A equals to 3 root 5, and you know what cos theta equals to and what sine theta equals to. Multiply all that and you'll find that the root 5s cancel out, and so it becomes 3 plus 12 plus 4 plus 3 root 5, and your final answer would then give you 19 plus 3 root 5. Okay, so that's why I thought it was a nice question. It's like the first few was straightforward, and you really got to think about it. So none of it is anything that you haven't seen. It's really getting you to think about the context of the situation. Okay, so have a look at that again. That's on your in the PowerPoint. It's on Schoology. Have a look at that question. But we'll call it a session now. It's 2:20. You got 3 minutes. You guys can pack up and head out.
Yes.